This video will go over how we factor quadratic equations. So far we've looked at vertex form, standard form, and zeros, as well as the graphs of parabolas, which are quadratic equations. Now we're going to look at factoring. Factoring is one of the best ways to find the zeros, roots, solutions, x-intercepts of a quadratic equation. Now, in order to factor, we must be in standard form. Okay, must be in standard form. Okay, now if we recall, standard form is ax squared plus bx plus c equals 0. We need to equal 0 because we're trying to find zeros. Okay, trying to draw those connections there. So, as we saw in class, factoring is just taking some addition and making it into multiplication. We're rewriting how area is. So you have x squared. We're trying to make squares or rectangles where we're just adding parts up. In standard form or in factored form, it will look like this. So there's standard. Factored is x plus m times x plus n equals 0. Standard form, factored form. They look different. They mean the same thing. So let's get straight to business. So here we go. We have x squared plus 4x minus 5 equals 0. We are in standard form, so we are good to go. So what we're going to do is we're looking for a product, numbers that multiply to make -5. Okay. And then, so product. And then in the bottom part, we're finding what two numbers sum to make 4. Okay, so I'm going to do some color coding. They sum to make 4. They multiply to make -5. Okay, now if I'm thinking of numbers that multiply to make -5 and add up to make 4, I'm thinking, this is my thinking, 1 times -5, -1 times 5. Okay? Now numbers that of this pair, if I do 1 plus -5, that equals -4. -1 plus 5 equals 4. So this is what I have to use. So -1 and 5 are going to go on the sides. Now we're going to go ahead and make a box. So my first term, x squared, goes here. My last term, -5, goes here. Now notice how -1 and 5, they add up to make 4x. So I'm going to take -1, so I have -x, 5x. And now we're going to factor out. We spent a lot of time on factoring out just of terms in order to help us with this method. So x squared and -x, they both have an x. 5x and -5 both have a 5. On this side, x squared and 5x both have x. -x and -5 both have -1. So our factors are x plus 5 and x minus 1. All right. Now we're going to do a slightly more challenging one where that leading number, that leading coefficient, is not 1. Okay, but the nice thing is that with our GCF method, it's not going to be that much different. So let's say that we are going to factor 6x squared, let's see, plus 11x minus 10 equals 0. So we are in standard form, A, B, and C. So let's go and make our x. We're looking for two numbers that add up to make 11. Add up to the middle number. Now this is where it gets tricky. This right here is A times C. Okay, so A and C. So that's 6 times -10 or -60. I'm going to go back briefly to the previous problem. The product was -5. 1 was a number in front of here, so 1 times -5 gives us -5. Okay, now what two numbers multiply to make -16 add up to 11? Here's my thinking. So I have -60, so I have 1 times -60, 2 times -30, 3 times -20, 4 times -15. Oh, I think that might be something that we want to look at, because 4 -15 equals -11. We've got -4 times 15 equals -16, -4 plus 15 equals +11. So we've got -4 and +15. Let's go ahead and draw our box. So we started with 6x squared minus 10, and we pull our -4x plus 15x. Let's see what we can pull out. So we both have an x here. Now 6 and -4, they both are divisible by 2. In this column here, 15 and -10 are both divisible by 5. Okay, that's where we have to make sure we know our factors, our multiples. Okay, now go across here. They both have an x in them. 6 and 15 are both divisible by 3. And -4x and -10, they both have a negative, and they both are divisible by 2. So our factors here are 2x plus 5 times 3x minus 2. All right, now you've got a couple problems to do on your own.